Good everyone, welcome to Pen Security. On today's content, we'll be talking about BGP campus network with a DMZ, firewall, NAT, and ACL, which is access control list. So I'll be showing you a small campus elite network that I've built, and this network is for Maxwell campus network. That's the scenario, and we'll be talking about the BGP at the edge. Also, the network is featuring a 2 ISP network connected to a router, and the network itself is segmented by VLAN, and we'll have a DMZ behind the firewall, and we also have NAT and ACL all together in the whole topology to give us a real-world secure network infrastructure. And looking at the picture we have here, just like this topology, we'll see we have 3 routers, we have 4 layer 2 switch, we have 4 layer 3 switch, and 2 firewalls, and we have VPCs, and we have a DC server, and we have a server, the DMZ. But before going in details, I want to bring the document, because I prepared a document for us to understand what we're doing. But the document, I won't talk much. I will just go briefly, just so we can understand what we're doing. And this topology is very, very good for MSc students, like master students that are struggling, mostly cybersecurity students are struggling to get a final project idea. This is not like already done job. This is more like an idea for you to venture into GNS3. I use EVNG and GNS3, and I use EVNG for my massive labs. Then I use GNS3 for just easy proof of concept labs like this, where I don't need to run heavy machines. When I deal with VXLAN, EVPN, I use my EVNG labs for those topology. So without wasting much of our time, because I will be very, very quick, so we can just get the idea, and I'll be adding this PDF to the video link so you'll be able to download it. Also, I'll be adding the configuration on my GitHub, so you can go to my GitHub to download the configuration, and there's a LaTeX file there folder. You can download the screenshots and everything as well, so you get a better understanding of the project itself. So I will just read through the abstract and go through the executive summary and go to the IP addressing. Then we'll come back to the topology so we can address it together. So this first line says Maxwell Campus Network. So the abstract: this document provides an executive style build record and technical verification pack for Maxwell Campus Network implementation. The solution delivers a segmented campus using VLANs, a controlled DMZ for critical services, and a dual ISP upstream connectivity using a BGP with strict default route acceptance. Maxwell is a small elite community campus with capped student growth. So it has a capped student growth over the next 5 years. The design prioritizes stability, operational clarity, security, while remaining upgrade ready. So this is executive summary. I won't just talk too much about it. We have the dual ISP, we have a default only inbound routing policy, which means we have one ISP that is active, the other ISP is passive. So when one ISP goes down, the other ISP take up immediately. So both ISPs are not working at the same time. We only have one working at the moment. Then when the one goes off, the other one will take up immediately. So that is how the topology is designed. It's more like a layer of redundancy, and it will also save cost. Then we have a dedicated DMZ. This DMZ is like we call it decentralized zone, where we have our web service, we have our DNS. It creates a kind of security to our important services. So we don't want to expose all our services to the internet. We need to have like a layer of security to our important services. That is how it is being configured in a real world enterprise. Then we have a firewall policy. So we have our access control list and our NAT. We all know NAT. NAT controls the inside and outside network. Then we have a DHCP. DHCP, it's just like a dynamic host configuration protocol. What it does is it handles IP addresses to host. So when a host tries to connect to a network, the network will also be requesting, will send an ARP request. Then ARP request will be accepted by a DHCP server, then supply the IP address. So for this IP address configuration, I configured it at the data center server. Regularly, most enterprises, they configure DHCP on the switch, but I didn't do that. I had to configure it on the data center server. Then I configured the DHCP relay on the core switch. When we get to the topology, I will explain all of this. So I just don't want to waste our time. Then this is a business concept. This is the why BGP for small campus. Why did they option for BGP? Then talking about the network topology overview. Then this is a baseline. This is a labeled network diagram. Then I want you to go through this fully annotated technical topology. This will give you an in-depth understanding of what I built in the network infrastructure. Then we're talking about the logical architecture. This is where I want to focus my attention right now, the IP addressing. So the network itself has 6 VLANs, but I excluded 2 VLANs for me because those 2 VLANs, they are not like regular VLANs. VLAN 50 is at the server at the data center. Then VLAN 60 is at the server, the DMZ. So those are secured servers, so they're not like public VLANs. But we have VLAN 10, 20, 34. These are regular VLANs that end users will have access to. So we have a reception, we have a library, we have engineering department, and we have earth and sciences. So earth and sciences and the library are specifically for the students, while the reception area is for like the hosts, like visitors, like these are regular people that comes around to the university. That's more like a security. Then we have the configuration itself for the subnets and the nodes. So you can go through the document yourself. I will add the link, like I said earlier, so you go through it and you understand it. I make sure I detailed it so you'll be able to understand the whole context. So let's go back to the topology and I will explain what we're having here. So when we look at this topology, we can see we have 2 NATs. This NAT now connects to ISP1. Then we have this second NAT. It connects to ISP2. Then both ISP1 and ISP2, they are connected to the core router. So the core router is the heart of the whole network. So it handles these IP addresses from the ISP. So network traffic travels from the internet direct to these routers and it comes to this core router which handles all the whole trafficking. So what happens here is if this ISP should go off, this one will come up. So this router handles every of those routing. That is its job. It handles it. Then moving forward, we have one firewall here. We have another firewall here. This firewall goes directly into the campus network. It acts as a security for the campus network. Then we have another firewall that points to the DMZ. I won't know what DMZ is all about. DMZ is more like a decentralized zone where we have our host services. If you're dealing with Docker containers, you're dealing with Docker, you're dealing with Nginx, dealing with Apache. These are services dealing with the database. These are where they keep database. It's secure. It's a kind of network that is segregated from the real network. This is not VLAN. This is another type of network security on its own outside the network. what it does is it secures, it's being secured from outside network. We have lot of access control lists at the DMZ, where, for example, you can't just ping the DMZ server, though you can still have access to it, more like have access to the web, have access to the, but they block, there are some policies that they block at the DMZ. Then we have the data center switch, and we have a DC switch. So let me start with the layer 2 switches first, then we'll go step by step. So let's talk about this layer 2 switch here. This layer 2 switch doesn't have any IP address SVI on it. No IP address is configured on it, no SVI. So what it does is it just pushes layer 2 packets. So it's acting as a layer 2 switch, no IP address, nothing. What it does is just to forward the packets. That's what it does. So packets will travel from here to here. The firewall will process it, then it will push it down, then goes down here. Then let's say, for example, I want to request for an IP address. So the packet will travel from here, it will go through this layer 2 switch, it will come to this distribution channel. Then STP protocol is also active on this topology, because STP protocols kind of block noise in the network. So it will look for the best route. It can go through this route, or it can go through this route. Then it will travel through this channel to get an IP address from here. I'm trying to simulate where we need an IP address from the DC server, because this is where we have our DHCP server and everything running. So this is just the context of this data center and this switch. So let me simulate an example. Let me try to see. So let's say IP DHCP. We're trying to request one IP address. Successfully, see, we got an IP address. So let me try to ping the gateway. So say we'll ping 10.10.100.1. We can't ping the gateway because it's security that we've assessed there, but we can ping the internet. Ping 10.10.100. Sorry, ping 8.8.8.8. Yes, we can have access to the internet. This is access control list. So you can't ping the gateway, but you can have access to the internet. The reason for the security in this topology is because of this firewall. So this firewall houses all the IP addressing. So for example, let me try to access it. This SVI, yes, SVI, I think this SVI. Let me check for the running configuration on this switch. So let's say Commodus. Yes. So say IPA. Let's just see the IP address on this switch. So let's look closely. Yes. So you can see we have loopback address here. We have loopback address here as 10.255.02. Then we have swap 1 as 172.16. That is what we have here. Then moving forward, you notice we have a VLAN bridge. This is VLAN 10 bridge. As you can see, the IP address here is 10.10.10.2. So let me see. We're supposed to be able to ping 10.10.10.100.2. Timeout because of the access control list that we've configured there. So we can't get access to the gateway, but we can get access to the internet. So let's keep that aside and check the configuration on the core router. So let me just clear these and then show IP interface brief. When we check the IP address here, you can see we have 192.51.100.2. This is the IP address that goes directly to ISP1. Then this is the IP address that goes to 1/0 that goes to ISP2. Then this is the IP address that goes to the firewall. This goes to the firewall. Then this is the IP address that goes to the other firewall down here. If you should remember, when I check the loopback for this particular loopback here, you notice we have a loopback address at this core here. If you should remember, yes, we have a loopback address 10.255.0.2, but this loopback is not addressing to this router. It is connected to this one, this firewall. But before we do that, let us check for BGP, because BGP is the concept of this whole topology. We'll say show IP BGP summary. Yeah, good. You can see. So these are the BGP neighbors. So we have 10.255.0.2, 10.255.0.3, 198.51.101. This particular one goes to the ISP1. This one goes to the ISP2. So the context of this BGP is just similar to when we're talking about VXLAN. So BGP is like traveling, or you have a mailbox that you want to send to a house. Then on going to the house, you don't have the address to the house. When you get to the house and you don't have the address, it will be a problem for you to locate the house because you don't have the address of the house. But when you have the address of the house, you just go directly to that house. That is how BGP works. BGP is like mapping the addresses of all the whole network. So when they try to send a message, it will already know where to forward the packets to, because it has mastered all the whole addresses in the network. We're not talking about hopping in the network now. We're talking about mastering the whole addresses in the network. So when I try to send a message, or when the packet tries to come into the network, when it gets to this router, it will know that, oh, it's going to this person directly. So it will just forward the packet directly to that person without making noise in the network. But this technology is quite different from VXLAN. VXLAN works with like VNI, but similar to this. But for the VXLAN, it marks the MAC addresses. It will know the MAC addresses, and it kind of creates a secure tunnel. But that is another topic for another day. But that is exactly how it works with the VXLAN. VXLAN will mark the MAC addresses, but for BGP will mark the IP addresses in the whole network. Then, if you have 5,000 network, when you run the show IP BGP summary, it will list out every BGP neighbors in the whole network, so it knows that, oh, this net messages is going to this person. So that is how it works. Let's try to check the IP route. Let's check the IP routing. So let me just run the code. Just say show IP route. Then say 0.0.0.0. Good. Trying to take it down. Yes. So you notice the IP route is for any subnet, any IP address, any subnet via this BGP, you can see through this BGP, the distance is 20, metric is 0, and the tag is 6500. Go through this port. This port is connected to the ISP1, like I said. So when the ISP1 goes down, ISP2 will take up. So this one will change to the ISP2. Go through that just one route. It will save the company, it will save the campus money, because you can't run both network at the same time. So when one goes down, the other one will come up. That's how it works. Let us try to ping to the internet. Let's see if we'll get internet access. Let's try to ping to the internet. Ping 8.8.8.8. See, successful. So there's successful message to the internet. Now let us check our firewall, because firewall is the heart of the whole network. If your firewall is not working fine, then you don't configure the good network. So interface, then IP brief, RIEF. Yes. So we have 3 networks here. The other one is came pre-installed with Cisco. I don't know what they did there. So this one goes directly to the router. It goes directly to the router. This is the uplinks that goes to the router. Then these ones are the downlinks that goes to the core 1 and core 2. We have 254.1, 254.5. So these are /30 IP. They are just point-to-point IP address. So when packet travels from here, it gets here, it travels to this port, and it travels to this port. So let's check the route. Show IP route. Yes, okay. So this is a route. So we have any IP address can go through the website, like through the ISP. Sorry for that. So any IP address can go to the ISP. So these are the connections. 10.10.0.0. This is like any IP address under this subnet, which is subnet 10, 20, 30, 40. Go through this port. Then this is a loop back for our BGP. This is our BGP. Connects directly to the outside, which is in and out. Then also we have this one that also connects directly in and out, BGP. Then we have 172.16.254. This route, it's the core 1 and core 2 IP addressing. So it has the inside and the outside network. That is how the firewall works. It protects the inside and the outside network, like it moves traffic in and out. So this is our IP addressing scheme. Then the next one is to check for let's check our access control list. What are we securing? That is one important thing. So this is show access. So I want to check for access control list. Also show access list. Yes. So on this now, we align BGP on all the whole network. BGP, because that is how we want to configure the network. So BGP is the network we're using. In regular networking, if you don't use BGP, you can use OSPF. But BGP is more enhanced in a large network like this. BGP is more enhanced. But for little network, let's say for example a mini office, we use OSPF. So we have OSPF, regular OSPF and the OSPF6 for IPv6 networks. So yes, we've done that. Now let's check this firewall. So you just show interface IP brief. Yes, we just have two IP addressing scheme. So this one goes to the internet. This one goes to the internet. Then this one goes to this server here, right? More like security. So yeah, it goes to the server there. So that is it for the server. So I want to try to see if I can ping. So this is our IP address. Let's take this down. I want to see if I can ping this machine from this user one. Let's say, for example, I want to access the internet. For me to be able to access the internet, I need to be able to ping to that machine. So let's paste. Yes, you can see. So there's a communication from the DMZ and the end users here. So let us try to get IP addresses for, because I know I told you we have different VLAN. So the first one was VLAN 10. This will be VLAN 20. Let's confirm. Let's see if we have, yes. So it's 10, 10, 20, 100. So VLAN 20. Then the next will be VLAN 30. Let's see if we'll get an IP address for VLAN 30. Okay. Yeah, see. Yes, we've gotten the IP address for VLAN 30. So let's say we'll get an IP address for VLAN 40. That's our last IP address scheme. So IP GCP. Correct. So let's see if we can ping to the internet. Because one thing is to get the IP, one thing is to see if we can get, we all having internet access. So let me close this and let me check for this as well if we have internet access. So we'll say we'll ping. Yes, we have internet access. That's correct. Then we'll check this one as well. We have internet. Do we need to do that? Let's check. Yes, we have internet access. So you can see the network is very, very redundant. So we have internet access on all the end devices. We have internet access. Then for this switch here, like I said, these are layer 2 switches. No IP address on the SVIs. These are just regular switch. Let me try to run it. It's coming up. Say enable. Show running. So yeah, let's see. It's taking forever to come up. So we don't have any IP address on these switches. What they do is they just forward packets. That's all. So what we just have there is just switch port access to the VLANs, but there's no configuration of IP addressing on this scheme because they don't have SVIs. Theirs is just a forward packet. So that was what we did there. And like I showed you earlier on, the gateway to this is here, located here. And what else again have I not talked about? Okay, let me talk about access. Let's check about the hits that are coming in. So I want to check the last trying to reduce it. Yes. So these are the requests so far. So we permit ICMP on any of these hosts. We permitted BGP, so that's why we have access to the internet. If we should deny any of this, because for the connection to leave from here to here, it goes through BGP. So BGP kind of broadcasts the IP address here. So when it broadcasts the IP address here, it will be able to be discovered in this section. So that is how it works. It's just like OSPF as well. For OSPF, you need a router ID. Then after configuring the router ID, you now position the IP addresses. You put the wildcard mask, then you configure it. Similar to BGP, but BGP masters, like it registers the IP address on the database itself. So when the traffic comes, it knows where to direct it to. So that is the concept of this whole campus network. Like I said, this project is very, very good, and it's very, very interesting for master's students that are skeptical or lost in ideas on what to do for their final project. You can play with GNS3 and work with regular projects like this. It will really go a long way, and it will help you. So that is it for today. I don't want to waste much of our time, and I would love to see you guys in our next video. I'm very, very sorry I have not been posting videos lately. I've been doing a lot of work, like I've been working outside the scene, so I have a lot of things I'm doing, but hoping by next year I will be back again with interesting and exciting videos like this. See you in our next video. Love to have you here. Please don't forget to love, like, comment and share our video. This will give me motivations to do more videos like this. Also, I will be keeping the documentation of this project in my portfolio. You can download it from there. Also, I'll be pushing everything on GitHub, so you'll be able to get access to it from GitHub. Love you guys. See you in my next video. Bye bye.